Hi, I'm Victor from Robotics, and today I'll be presenting intuitive virtual reality human-robot interface system with volumetric telepresence. Tele Operation enables users to operate a robot in remote locations by enabling interaction with the robot's environment and the ability to perform physical tasks. VR Tele Operation is increasingly being used within nuclear decommissioning, robotic construction, and space robotic industries to the potential of offering greater situational awareness and accurate sense of depth and multiple weaving orientations for complex physical operations. Advanced Mechanics Assistance System is a VR-based system that can be used to operate physical robots using intuitive gestures and provides 3D perception of the physical robot's environment, allowing the users to intuitively teleoperate or teleprogram a robot over a network. The Amos system comprises of three components, the first one being the Amos VR App. The Amos VR App is a human-robot interface software which renders the VR environment using consumer-grade VR headsets and uses OpenXR for the back-end processing. It features volumetric telepresence, interactive digital twin, teleprogramming, as well as immersive simulation. The next component of Amos is the RoboKit, which is an edge computer that handles communication between the Amos VR app and the robot controller. It performs real-time inverse kinematics computation and it handles errors such as robot collision or faults, which allow a safe operation. The last component is the SenseKit, which comprises of an edge computer and an RGB sensor and enables real-time volumetric data capturing and streaming. It uses statistically lossless depth compression and hardware-accelerated RGB compression for ensuring a less than 150 milliseconds latency and requires about 10 megabits per second of bandwidth.
And here is a quick demonstration of the Amos VR app. This demo uses volumetric fusion of two RGBD cameras. And here is a demonstration of the recording capability.
Thank you for listening. You can find more details about the Amos system on Robotics' website.